All right, greetings, scholars. So we are entering the final stretch, right? So this this should be week 13, and this week will count as we have 3 sections remaining. So this will be the last of the new content, and the rest is just wrapping things up, submitting all our assignments and things of that nature. So here we're going to be continuing chapter 6 on exponential and logarithmic functions, and we're going to be working on section 6.3, logarithmic functions. A few learning objectives. In this section, you will convert from logarithmic to exponential form, convert from exponential to logarithmic form, evaluate logarithms, use common logarithms, and use natural logarithms. A logarithm base b of a positive number x satisfies the following definition. For a positive x, positive b, and b not equal to 1, y equals log base b of x is equivalent to b to the power of y b to the power of y equals x, right? So the takeaway here, when we're given this log form, if we want to convert it to exponential form, we take the base of the log, it swings over to the other side of the equal sign and becomes the base of our exponent, all right? So these are equivalent. These are 2 different ways of saying the same thing, all right? So again, given the log form, if we want to write it in exponential form, the base of the log swings to the other side of the equal sign and becomes the base of the exponent. And vice versa, if we're given the exponential form, we want to write it in log form, the base of the exponent swings to the other side and becomes the base of the log. Okay, so these are 2 different ways of writing the same thing. We read log base b of x as the logarithm with base b of x, or log base b of x. The logarithm y is the exponent to which b must be raised to get x. Also, since the logarithm and exponential functions switch the x and y values, the domain and range of the exponential function are interchanged for the logarithmic function. Therefore, the domain of the log function with base b is going to be 0 to infinity, the open interval from 0 to infinity. The range of the logarithmic function with base b is going to be all reals. Okay, that's fine. Oh no, I didn't prepare that one properly. Can we take the logarithm of a negative number? Right, there will be no. Because of the base of an exponential function, let me see, is it here? No. Because the base of the exponential function is always positive, right? So given an equation in logarithmic form, how to convert it into an exponential form? Examine the equation y equals log base b of x and identify b, y, and x. Rewrite log base b of x equal to y as b to the y equals x. Yeah. Okay. So they're basically, the base of the log swings to the other side and becomes the base of the exponent. That is essentially the same thing here. So we're asked to write the following logarithmic equations in exponential form. Okay. So let's see. So for part A, we have log base 6 of the square root of 6 equals 1/2. Okay. Let me see. So if we're going to write this in exponential form, the base of the log swings to the other side and becomes the base of the exponent. So then we'll have, you can write it as the square root of 6 equals 6 to the power of 1/2. Okay, and then part B, we have log base 3 of 9 equals 2. Again, if we want to write this in exponential form, the base of the log swings to the other side and becomes the base of the exponent. So then this is going to be the same as 9 equals 3 to the power of 2. Okay. So in these examples, we want to convert from exponential form to log form, right? So in part A, we have 2 to the power of 3 equals 8. Same deal. The base of the exponent swings to the other side and becomes the base of the log. So this is going to be the same as 3 equals log base 2 of 8. And for b, we have 5 squared equals 25. So if we're going to write this in log form, the base swings. We're going to have 2 equals log base 5 of 25. And then for c, 10 to the power of negative 4 equals 1 over 10,000. Okay. Same deal. The base of the exponent swings to the other side and becomes the base of the log. So we'll have negative 4 equals log, or you can just write it as log, because with common log, when you don't write a base, then there's an implied 10, right? So you can write this as the log of 1 over 10,000. Yeah, we're good. Okay. So given a logarithm of the form y equals log base b of x, how to evaluate it mentally? Rewrite the argument x as a power of b. So basically rewrite the log as an exponential, then use previous knowledge of powers of b, identifying y by axis to what exponent should b be raised in order to get x. Okay, so let's see this in action. We're asked to solve this guy without using a calculator, right? So we're going to start with, we have this y equals log base 4 of 64. We're going to rewrite it as an exponential. So we're going to take the base and swing it to the other side. So then we're going to have 4 to the power of y equals what, 64? So now to solve something like this, if we can get these two exponential expressions to look similar, like either have the same base, then we can equate the exponents. Now let me see, 64, is that a power of 4? 4 times 4 is 16. I think that's what, 4 to the power of 3? 16 times 4 is 40 plus 24, 64. So 64 is the same as what, 4 to the power of 3. So notice we got these two expressions to look similar. So then at this point we just equate the powers. So then long story short, I guess I can do this. Y equals 3. That's fine. So evaluate this without using a calculator. Okay. So again, we have y equals log base 3 of 1 over 27. All right. So then the base of we're going to rewrite the log as an exponential, so it swings to the other side. So then we have 3 to the power of y equals 1 over 27. Okay. So is 27 a power of 3? Let me see. 3 times 3 is 9, times 3 is 27. So then we can rewrite the right-hand side as, now, let me see. That's 3 cubed, so we're going to say 3 to the power of negative 3. Because 3 to the power of 3 is 27, and then we make the power negative to make it 1 over 27. So then from here we get that y equals a negative 3. Okay. Now we can actually evaluate this in the calculator, but there's something that we need to talk about first before we do that. Because most calculators, you can't just type it in the way you see it, because you don't have a way to address that base. And so there is a way to do it, but we'll talk about that momentarily. Now, if you want to look it up, there's this technique called the change of base formula. In case it should pop up to where we talk about it, but in case it doesn't, just do a quick search on change of base formula. It's really easy, but I'm trying to hold out for when it shows up in the notes. Okay, so the definition of the common logarithm, a common log is a logarithm with base 10. We can also write log base 10 as just log of x. The common logarithm of a positive number x satisfies the following definition. Y equals log of x is equivalent to 10 to the power of y equals x. Right, so that's what I was just saying a moment ago. The implied base of common log is base 10, right? So given a common logarithm, how to evaluate it mentally, rewrite the argument as a power. So rewrite the log as an exponential and then use the properties of exponents to solve. So evaluate this without using a calculator. We're going to have y equals the log of 1,000. Okay. So again, when there's no base written, there's an implied 10 here. And then from there, we can rewrite it as an exponential. Okay. So then we're going to have 10 to the power of y equals 1,000. Okay. So 10 to the power of y equals what? 10 to the power of 3. I don't know why all of these are 3. So then y equals 3. Okay. So given a common logarithm with the form y equals the log of x, how to evaluate it using a calculator? Okay, so this is common log base 10. So that one you just type it pretty much straight. So just, you might want to practice that. Just that you can generate this. This one you can just put directly into the calculator. Okay. So 2 point something. That's interesting. Okay, so that's it. I'm going to leave that as an exercise for you because it's just with the calculator. The amount of energy released on one earthquake was 500 times greater than the energy released from another. The equation 10 to the power of x equals 500 represents this situation, where x is the difference in magnitudes on the Richter scale. To the nearest 1,000, what was the difference in magnitude? Okay. So we're given 10 to the power of x equals 500, right? So let's rewrite this as a log. So then we're going to have x equals, it would be log base 10. When it's base 10, when you have log base 10, you don't have to write the 10 because it's implied. And then so in the calculator, we would just take the log of 500. Let me see if Siri can do it. Siri, what's the log of 500?
I found some web results. I can show them if you ask again from your iPhone.
Let me try one more. Hey Google, what's the log of 500?
The common logarithm of 500 is approximately 2.7.
She said approximately 2.7. I would need my calculator to get those additional decimals. Let me try one more time. Hey Google, what's the log of 500 to 3 decimal places?
Sorry, I don't understand.
It's okay. So you see it there. They got 2.699, right? We would need the calculator to get those decimals. But that still rounds to 2.7. So, I'm just not using the calculator just because. Okay. So a natural log is a log with base e. Rewrite log base e of x, we write it as ln of x. The natural log of a positive number x satisfies the following definition. For a positive x, y equals the natural log of e is equivalent to e to the power of y equals x. We'd read ln of x as the logarithm with base e of x or the natural logarithm of x. The logarithm y is the exponent to which e must be raised to get x. Okay. So given a natural logarithm with the form y equals the natural log of x, how to evaluate it using a calculator. So this one we're going to use ln, right? So ln is nothing but common log base e. Evaluate this using a calculator. So again, this is another calculator one. I'm just going to leave this as an exercise so that because one is like, because everybody's calculator is different, you know, and it's not too difficult to type that in the calculator. Okay, so it does take a little bit of effort on your end to see how to work your personal device. So you just want to make sure you're getting the same result at the bottom that you see there. Okay, I think that actually brings us to the end of this section. Let's see what we have. Hopefully that change of base it should pop up in the next section. It should. So we're gonna go ahead and end this session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.